Here we're going to look at how we can find the angle between two vectors. So if we're given the following two vectors, if we have, let's say, one vector here, we'll call this one u, and we have another vector here, and this is maybe vector v, we want to be able to calculate what is the angle between these two vectors. And the formula for that is simply we want to take the cosine of theta, that's going to be equal to u dot v. So here we're going to take the dot product of the two vectors, and then we're going to divide by the magnitude of u multiplied by the magnitude of v. So this here is the simple formula for finding the angle between two vectors. So let's see if we can do that. If we have one vector here, which is 3, 2, and we have another vector, 4, 0. And we want to determine what is going to be the angle between these two particular vectors. Now, before we actually go to the formula, I want to actually sketch out what we're looking at. So we have u, which is over 3, and then up 2. So over 3, up 2. So that vector is going to be roughly right about here. And then if we're looking at v, it's simply going over 4. So 1, 2, 3 is going out to here. So that's just moving right along the x-axis. And we want to know what's going to be the angle theta here between the two vectors. So if we go to the formula, we're simply going to take the cosine of theta, and that's what we're looking for is the angle, and we need to find the dot product. So we would then take 3, 2 multiplied by 4, 0, and that's going to be divided by the magnitude of u. Now remember, the magnitude is simply the square root of the first component squared, so that's 3 squared, plus the second one, which is 2 squared. And then we need to multiply that by the magnitude of v, so that means we would take 4 squared plus 0 squared. And now all we have to do is simplify. So bring down, we're still setting this equal to the cosine theta. So the dot product says we're going to take 3 times 4, which would be 12, plus 2 times 0, which is 0. And then on the bottom, we're going to get the square root of 3 squared plus 2 squared. So that's going to be 9 plus 4, which would be 13. And that's going to be multiplied by 4 squared and 0 squared. So 4 squared is 16 plus 0, so that's simply 16. And here we could simplify this a little bit. We could take cosine of theta, set this equal, this is going to be simply 12 on top. And then on the bottom, we could just multiply the 13 and 16 together. So square root of 13, or we could just write it as the square root of 13 times 16. And if we were to take 13 times 16, we would certainly get 208. So we would end up with the square root of 208. And here, we're not going to worry about rationalize this because we're actually looking for the particular angle. So if we're solving for the angle, then we have to take the inverse cosine. So the inverse cosine of 12 over the square root of 208. So we would just simply go to the calculator and type that in. So second cosine. Okay, and then we need to type in 12 over the square root of 208. So 12 divided by the square root of 208. And we get an answer of 33.69. So I may just make this easy enough and round it to 34 degrees. So therefore, theta is equal to 34 degrees. And if we look at the picture over here, it looks like reasonable enough that this angle could certainly be 34 degrees. Okay? All right, the next example we have, and once again, maybe you want to try this one on your own. If we have u is equal to 2i minus 3j, and v is equal to I, or to be 1i minus 2j. And we want to find the angle between these two vectors. And once again, if you want to, we can actually kind of draw a little picture. For the first one, we're going over 2 and down 3. So here's u, and then v is going over 1 and down 2. So based on this, it looks like our angle between the two vectors is going to be relatively small. So here, once again, we would take the cosine of theta, and now we need the dot product. So that's going to be, and if you want to, I'm going to write this more, instead of I and j, I'm going to write it in the component form of 2 comma negative 3 multiplied by 1 negative 2. I just think that's a little bit easier to work with. And then, of course, on the bottom, we need the magnitude. So that's going to be 2 squared plus negative 3 squared, and then 1 squared plus negative 2 squared. So the dot product, we're going to take 2 times 1, so we're going to get 2 plus negative 3 times negative 2 would be a positive 6. So we get 2 plus 6. And then on the bottom, we have the square root of 2 squared plus a negative 3 squared, so that's 4 plus 9. So there we're going to end up with the square root of 13. And over here, we're going to get 1 plus 4, so that's the square root of 5. So therefore, the cosine of theta is simply equal to 8 over, and then 13 times 5. If we multiply that, 13 times 5, you're going to get 65. So therefore, this would be the square root of 65. So here we're simply going to go to the calculator, and we would type in second cosine 8 divided by the square root of 65, and we get an answer of 7.12. So I'm simply going to round that to 7 degrees. So we have an angle of 7. And from looking at the picture, we knew that it was going to be a fairly small angle, so that seems reasonable for an answer. All right, I do want to look at one other example here, and this one should be easy, but people tend to make it a little bit more difficult. If we have our vector written this way as a cosine of pi over 3 I plus the sine of pi over 3 j, and then our second vector is the cosine of 3 pi over 4 I plus the sine of 3 pi over 4 j. So here we're kind of using our trig functions like we did in a previous video in order to represent our vector. And here we want to find the angle between the two vectors. And this is going to be really easy if you think about it. If we look at a picture, if we look at u, that's located at pi over 3. Well, pi over 3 we know is roughly right about here. So here's this vector. And then if we look at v, which is 3 pi over 4, that's going to be over here. So if we're trying to find this angle theta that's between the two vectors, how can we do that? Well, keep in mind this angle is located at pi over 3, and this angle all the way over here, whoops, this particular angle is what? That's going to be 3 pi over 4, right? So if we're looking for the angle in between, we're simply going to take the 3 pi over 4 and take away the pi over 3, and we'll be left with the angle in between. Because here they actually give us the two angles. So all we have to do is subtract to find our angle. So in that case, with a fraction here, we need a common denominator of 12, so 4 into 12 is 3. 3 times 3 is 9, so we get 9 pi over 12. 3 goes into 12, 4, so times pi, that would give us 4 pi over 12. So therefore, if we subtract, we get 9 pi over 12 minus 4 pi, so we would have 5 pi over 12. So that gives us the angle between the two vectors. So once again, if you're looking for the angle between two vectors, we can simply just use the formula cosine theta equals u dot v divided by the magnitudes of u times the magnitude of v.